Welcome to another exciting episode of Unique Life. This is the F35 Lightning II, the U.S. Air Force's newest and most technologically advanced fighter jet. The F-35 is arguably the most advanced plane ever made. A stealth fighter plane, combining and improving on the capabilities of the F-16, AV-8B Harrier, and B-2. A highly maneuverable fighter plane capable of attacking both airborne and ground-based targets. A plane fitted with the most advanced sensors and computer systems, sharing information almost instantly with allies, without compromising stealth, and presenting the information directly on a heads-up display on the pilot's helmet visor. It can fly at supersonic speeds. As fast as 1,200 miles per hour, has an exterior coated in a radar-absorbent stealth material, making it virtually undetectable enemy reader, and combines a weapon system with the most advanced sensor suite ever installed on a fighter jet, allowing the F-35 to both control and dominate battlefield. In this video, I will explain all about the F-35's incredible capabilities. Get ready because this is F-35. Do you have ever knew the flying experience about this kind of fighter jet? Absolutely not. It is pretty much like you are at the hill of a front seat roller coaster, but you are at the controls the whole time. The aircraft has three main variants: the conventional takeoff and landing F-35A, the short takeoff and vertical landing F-35B, and the carrier-based F-35C. This is fifth-generation air-to-air fighter jet with stealth technology. Means we can get in closer to the enemy. We can shoot our missiles, drop our bombs before we are targeted. Which is we can roll back those air defenses, ground systems, and our priority mission is being a multi-role SEAD fighter, so suppression of enemy air defense. We can see single seat, radar in front, and it's so huge powerful AESA radar that can target multiples air-to-air and air-to-surface tracks at the same time. We can see DAS cameras, so an IR camera in there. There are 6 of them around the aircraft, fusing a 360-degree video that you can put onto your visor. That allows you to see through the jet and see through yourself as you're flying around. It's include a missile warning system. You can see under the chin EOTS system, electro-optical targeting system. It's similar to like a sniper or lightning pod to generate on the ground to track air-to-air targets and send coordinates from that to the bombs. That is what allows to do deliberate targeting or dynamic targeting of moving targets. The aircraft manufactured by Lockheed Martin, the aircraft powered by the most powerful and most advanced jet engine. The engine is capable of producing 43,000 pounds of thrust, enabling the aircraft to be capable of taking off vertically and fly maximum speed of Mach 1.6 and an altitude of 50,000 feet. The F-35 can generate 191 kilonewton of thrust. The F-35 engine has a much larger fan and bypass ducting. This is the most advanced fighter jet. The F-35 Lightning II, a distinguishing feature of the aircraft, is its advanced $400,000 helmet that enables high level of situation awareness and long-range lethality. The heads-up display incorporated into the pilot's helmet. Traditional heads-up display, like those of the F-16, are incorporated into a panel in the cockpit, a panel which the pilot cannot see when scanning their environment. This helmet is giving them X-ray vision and night vision. It is processed and displayed through a projector inside the helmet. Inside this transparent faceted box underneath the aircraft is a suite of sensors. The F-35 also featured high-quality radar-absorbent materials to reduce its radar signature. The aircraft also has reduced infrared and visual signatures, as well as strict controls of radio frequency emitters to prevent being detected in heat by enemy weapons. The radar antenna hidden inside the nose of the F-35. This is a scanned array radar that works very differently to traditional mechanical radar. We can see metal plates set in rows in the F-35 phase array antenna. There are total around 1,600 antennas. Traditional phase array antennas are passive, meaning every antenna in the array is driven by a single transmitter and receiver. This would mean it can only point in one direction, and if it encountered 2 enemy planes flying side by side and they split up, the passive phase array antenna would no longer be able to track both of them. However, the F-35 phase antenna is an active phased array, meaning each and every one of these antennas is an individually driven transmitter and receiver. meaning the F-35 can track multiple targets at once with zero moving parts. Speaking of weapons, the F-35 can carry 4 internal ordnance. It can also include external weapons packages, which can increase its full armament to 10. Other than that, the F-35 is equipped with advanced avionics to improve its capabilities. Flares are effective decoys for heat-seeking missiles, but they do nothing to prevent radar-guided missiles. In the face of guided missiles proliferation and continued growing sophistication in the technology, a new decoy system was developed. This new technology is released from this panel. When needed, this access door opens and transmitter begins to reel out to a safe distance behind the plane. It has 3 levels of countermeasures to protect the F-35 from attack. First, it actively jams missiles while they attempt to lock onto their target by emitting jamming signals which the onboard computer computes and delivers to the emitter through the fiber optic tow line. If radar manages to obtain a lock, it then begins to attempt to break the lock, disrupting the tracking algorithms guiding the missile towards its target. Finally, if all is lost and the missile is bearing in on the aircraft, the emitter begins to simulate the aircraft's radar signature, drawing the missile towards it as a decoy. These serrated hatches hid critical components of the F-35, but more can be done to reduce edge scattering in these locations. The surface of the plane itself is composed of specialized radar-absorbing material. In 2010, Lockheed Martin filed this patent for a carbon nanotube-infused composite material that can absorb radar waves from 0.1 MHz through to the 60 GHz. This is an incredibly wide range of frequencies. The largest hatch on the plane is strangely not serrated, and this is for good reason. This hatch hides the powerful lift fan within the airflow. In and out of this lift fan needed careful consideration. The lift fan is essentially a tiny helicopter capable of generating 85 kN of vertical thrust, and in doing so it creates a lower pressure zone above the plane, violently sucking air into the aircraft at a 90-degree angle. This air has to travel over the hood to reach the inlet, and thus the hood needs to allow air to smoothly pass over it without creating too much turbulent flow, which would lower the performance of the lift fan. This is why the inlet door is not serrated, as the sharp edges would cause distortions in the flow. This hood alone went through several design iterations to optimize the airflow flowing over it. The F-35 not take off vertically, instead using the lift fan and directional thrust of the rear nozzle to take off on extremely short runways. The mechanics of this nozzle are another wonder to behold. Rotating the central piece can take the nozzle from a degree turn to 45 degrees. This position is used for short takeoffs, splitting the engine's power between thrust and lift. This mode is just as impressive as vertical takeoffs. Watching the F-35 take off over such short distance is incredible. You can see the rear nozzle quickly adjusting its angle of thrust, in sync with the rear elevators, to adjust the pitch of the plane to ensure a safe takeoff. You can see for vertical landing, the final nozzle segment can rotate to provide the full 90-degree turn. Don't forget to hit that like button and subscribe for more fantastic content.